Last example of trinomial factoring. Inside of it is going to be a binomial factoring, so I'm trying to cover two things at once. Again, the first thing you want to tackle about factoring this is pulling out the greatest common factor. It will make your life a lot easier and get the numbers a little bit smaller. So the GCF between 3, 6, and 24 is going to be 3, of course. So we're going to pull out a 3. That'll leave behind, let's see, at x to the fourth minus 2x squared and a minus 8 inside the parentheses. So all we're going to do is factor what's left inside, the x to the fourth minus 2x squared minus 8. It looks like, if we kind of ignore the 3, that it is a lead coefficient of 1. But to be safe, I'd highly suggest multiply the first number times the last number. So in this case, it'll be 1 times 8, still gives you the 8. So we're going to find factors of 8 that subtract up to a negative 2. Well, the only factors of 8 that subtract up to negative 2 are, well, 2 and 4. So we're going to take this middle term, and we're going to separate it into a 2 and a 4. And again, order doesn't matter. If you put the 4 first and the 2 second, that's okay. The middle term has an x squared, so I need to attach an x squared to both of them. Alright, so when I do add them or subtract them together, I'm going to get a number with a variable of x squared. I need a negative 2, so the bigger one's going to have to be negative, and the smaller one's going to have to be positive. Alright, and then again, like before, just bring down the beginning term, x to the fourth, and the ending term, the minus 8. Alright, and then just group and factor. GCF of the first two is going to be x squared. Left behind will be x squared plus 2. The GCF of the second two terms is going to be a negative to begin with, and then a common factor between 4 and 8 would be 4. And then left behind will be a positive x squared after you do your division. Negative divided by negative is a positive. And negative 8 divided by negative 4 is a positive 2. And again, the two terms have a common factor, x squared plus 2, and that leaves behind x squared minus 4. Don't forget, there was that first number to come down, and we need to bring that GCF down with the problem. Alright, we're not done yet though. This x squared minus 4 is the difference of perfect squares. This factors into the nice little pattern of the square root of the first one and the square root of the second one. So we're going to get 3x squared plus 2. And then the square root of them would be x minus 2. And with the difference of perfect squares, you also get, basically its conjugate, x plus 2. So x squared minus 4 factors into x minus 2 and x plus 2. This only works if it's the difference of perfect squares, not the sum of squares. And this whole thing would be our solution of the factors of, or the factoring of 3x to the fourth minus 6x squared minus 24. Again, if you multiply this all out, that's what you're going to get. And then we're done.